Hey everybody, welcome back. This week we're going over a project called Linked List Implemented as a Stack and a Queue. This program implements and compares the performance of two data structures, a stack and a queue, both using doubly linked lists. It measures the time taken to perform insert and delete operations on these data structures for different numbers of elements, 100, 1,000, 10,000. The results are displayed in a formatted table allowing for easy comparison of the performance characteristics of stack operations. So let's take a look at the header inclusions and namespace declarations. The program begins by including the necessary C++ standard libraries and declaring the use of the standard and chrono namespaces. These provide essential functionality for input and output, time measurement, random number generation, and data structures. Next, we have the node class. This class defines the basic building block of both the stack and the queue. Each node contains an integer data value and pointers to the next and previous nodes in the list. Next, we have the stack class. The stack class implements a last in, first out LIFO data structure using the doubly linked list. It includes methods for inserting elements at the top of the stack, removing elements by value, and printing the stack contents. Next, we have the queue class, and the queue class implements a first in, first out or FIFO data structure, also using a doubly linked list. It includes methods for inserting implements at the rear of the queue, removing elements by value, and printing the queue contents. Then we have the measure time function. This template function measures the time taken to perform a specified number of insert or delete operations on a given data structure, stack, or queue. It uses the C++'s chrono library for precise time management and generates random numbers for the operations. Then we have the main function. The main function orchestrates the performance testing. It creates instances of the stack and queue. It defines the number of operations to perform, so 100,000, 10,000. It sets up a formatted table to display results. It iterates through each operation type, such as the insert and delete, and the data structure, stack and queue. For each combination, it measures the time taken for the specified number of operations, and then it prints the results in a formatted table. When we run the program, we can note the performance from the output. So for the insertion performance, both the stack and the queue show similar performance for the insertion operations. The time complexity appears to be roughly linear, as the time increases proportionally with the number of items. Queue insertions are slightly faster than stack insertions, but the difference is minimal. For 10,000 items, both structures complete insertions in under 3 milliseconds. Then when we look at the deletion performance, the deletion operations show significant differences. Both structures exhibit nonlinear growth in deletion time as the number of items increases. Stack deletions are faster than queue deletions for larger data sets, 1,000, 10,000 items. For 10,000 items, stack deletions take about 0.45 seconds, while queue deletions take about 0.53 seconds. When we look at the overall efficiency, the insertions are significantly faster than the deletions for both data structures. The stack appears to be more efficient for deletion operations, especially with larger data sets. The difference in performance becomes more pronounced as the number of items increases. This analysis suggests that the choice between stack and queue should depend on the specific use case and the frequency of insertion versus deletion operations in the application. So that's about it this week. So if you have any questions, please leave a comment below and hit the thumbs up, and I will see you all next time.